Before we can analyze a structure, we need to know the loads that might act on the structure. Let's start with a warm-up activity. You'll need something to write on. I want you to take 1 minute, 60 seconds, to write down as many different causes of force on a structure as you can think of. Consider different types of civil engineering structures. When I say causes of force, I don't mean gravity. What might gravity act on that causes force on a structure? Pause this video, get something to write on, then start your 1 minute timer. Okay, pause now. I am guessing that somewhere on your list, you have the self-weight of the structure. You probably also have people on your list. People cause force due to their weight, but they cause different force due to jumping, and they cause force in a different direction when swaying. What about the chairs and desks and other furniture? Perhaps you have cars or trucks on your list. We must consider their weight and the force generated when they bounce. Yes, vehicles bounce. They do it every time they go over something like an expansion joint or a speed bump. They generate force in a different direction when braking. We need to consider impact of the vehicle as well. What about the force of a flood or tsunami, or even the water in a pool? Grain and other granular materials stored in a structure cause force. What about a landslide or backfill? Just watch the news and you know that hurricanes and typhoons have very high wind speeds that generate a lot of force. What about blast? Explosions can be a risk in manufacturing and storage, not just malicious attacks. What about the force generated by an earthquake? Did you consider some extreme causes like a volcano? Or how about a meteor impact? Your list, combined with mine, still does not cover all the possibilities that engineers should be considering. So codes are developed to give us a way to organize and consider the various loads. The codes group the different causes into categories. Let's talk about the most common load types or categories. Dead load refers to the self-weight of the structure. We call it dead because it does not move around or change. It is always present. Dead load includes the weight of the structural members like floors and walls. It also includes the weight of attachments that are likely to be permanent. For example, ventilation ducts, pipes, light fixtures, and electrical conduits. Loads due to the use or occupancy of a structure are called live loads. We use the term live because this type of load is not permanent. Live loads include the weight of people, furniture, appliances, boxes, movable partitions. Materials that keep their shape when stored would be considered live load, but some materials shift to fill their container, like grain or sand. We consider these loads in the same category as soil pressure. We use the term fluid loads for stored liquids. These are in a separate category from flood loads because we know maximum heights and pressures pretty well for stored liquids. We store liquids for industrial purposes, but we also see fluid loads for water towers and swimming pools. Snow is a load that depends on the location of the structure. All of the load magnitudes that we obtain from codes are based on probabilities. In tropical locations, the probability of any snow load is extremely small. In some locations, the probability of snow is very high, but the total load magnitude is still small. In some locations, there is reasonable probability of very large snow loads. Wind and seismic are two other load categories that are based in part on the geographic location of the structure. The wind load that a structure experiences is a function of the peak wind velocity, the terrain near the structure, the shape of the structure, and the height of the structure. We use the term seismic load to represent the effect of an earthquake. The load that the structure experiences is a function of the frequency and magnitude of ground movement, the stiffness of the structure, and the distribution of mass throughout the structure. Calculating the magnitudes of each of the load types is outside the scope of what we have time to cover. The codes and their commentaries cover that.